Good morning, students. Welcome to the class. In the previous class, we completed Unit 7. Okay. So, today we have discussed about Unit 8. Unit 8 is your three-dimensional viewing. Okay. So, in three-dimensional viewing technique or visualization technique, we have convert viewing the object from three-dimensional to two-dimensional object. Okay, according to the camera analogy, how the object is look likes and how the object is displayed in 3D to 2D. Okay, so some parameters are considered when project the 3D object to 2D objects. One is your viewpoint, another is your view direction, then aperture. Okay. A view of a 3D scene is generated in the viewpoint, view direction and aperture must be specified. Okay. These parameters are analogous to the adjustment made by a photograph when he takes the picture a real scene. Viewport means location to the camera and view direction means direction in which it takes and aperture means the lens which determines by how much of the scene will be included in the picture. All these things are included in the three-dimensional viewing. So let us discuss in detail what is three-dimensional viewing. Okay. Three-dimensional viewing. Okay. Viewing in 3D involves the following consideration. First is we can view an object from any spatial position. That means in front of the object, behind the object, middle of the object or inside an object. That means one object we can see in different point of view. Okay. Then 3D description of object must be projected onto the flat viewing surface of the output device. Okay. And the clipping boundary enclose a volume of space which the object is covered. Okay. So in this diagram, how to view and how to project a object, projection a object. According to the camera analogy, first we set up your tripod, then point the camera at the scene which we want to picturize or we want to capture. Okay, so this is known as viewing transformation. Then in the next step, arrange the scene to be photographed into the desired composition. That means in which way we take the picture or we capture that picture, that is known as modeling transformation. Okay, then choose a camera lens or adjust the zoom and how it enlarge it or how it decrease or how is the size is zooming or size is increase or decrease, in which size we can take. Okay, that is known as projection transformation. Then last one is our determine how large you want the final photograph to be. After that we finalize that the final photograph is how much large or how much short. Okay, so this one is our viewport transformation. It might be enlarged or it might be reduced. Okay, so according to the camera analogy, all these steps we can follow it. Okay, so here this one is our, according to the camera analogy, how to take a picture and how to set the camera, and this one is our computer analogy to how to take the picture or how to set the computer projector focus. Okay. Next come to the point viewing pipeline. Viewing pipeline concept we also study in 2D viewing. Okay. Okay. Here we convert the image from modeling coordinates to device coordinate. Okay. So in the viewing pipeline, first we the object is in a modeling coordinate. Then we use the modeling transformation to convert it into the world coordinate. Okay. After it convert the world coordinate, then we convert it into the viewing coordinate. To convert the world coordinate to viewing coordinate, we can use viewing transformation. Okay. These things up to this one is our three dimensional. Okay. After that, when the object is converted to 2D, in 3D means here three directions are there: x coordinate, y coordinate and z coordinate. One additional coordinate are there, which one is our z coordinate. But in 2D only two coordinates are there, one is x coordinate and another one is y coordinate. After this one is our three dimensional conversion. Okay. Then after that, when we convert it into the device coordinate, that means that object is in a 2D viewing. Okay. So when viewing coordinate can convert it to the project coordinate, we can use the technique projection transformation. To use the technique projection transformation, we can convert the viewing coordinate to projection coordinate. After that, we can use workstation transformation to convert it into the display device coordinate, or the how the picture is looks, or final picture looks in a 2D form. So that means the projection coordinate can convert to the device coordinate by using the technique workstation transformation. So this portion is our 2D parts. So in this way we can convert a 3D image to 2D image. Okay. That means first we convert the modeling coordinate to world coordinate by using modeling transformation, then world coordinate to viewing coordinate by using viewing transformation. After that, viewing coordinate can convert to the projection coordinate by using projection transformation, and projection coordinate can also convert the device coordinate by using workstation transformation. In this way, viewing pipeline works. So let us the steps what are included one by one. First step is 3D pipeline are similar to the process of taking a paragraph. Okay, as shown in the above figure, that initially we have modeling coordinate of any object which we want to display on the screen. Okay, by applying modeling transformation, we convert modeling coordinates to world coordinate, which gives which part or portion to be displayed. That means when we convert modeling coordinate to world coordinate by using the technique modeling transformation, it will gives the portion which we want to display. Okay. Then by applying viewing transformation, we obtain the viewing coordinate which is fitted in viewing coordinate reference frame. Okay, by using the viewing transformation. Then in case of 3D object or three-dimensional object, we have three-dimension coordinate. Which one is our x coordinate, y coordinate and z coordinate. Okay. Three-dimensional coordinate, but we need to display that object on two-dimensional screen. So we apply projection transformation on it, which gives the project coordinate. When we convert modeling to viewing coordinate, it will only 3D coordinate, okay, or viewing coordinate reference frame. It can only fit it. But when we convert it to the 2D image, we can use the projection transformation and to convert it to the projection coordinate. Okay. Then finally, the projection coordinate is converted into device coordinate by applying the workstation transformation, by which gives coordinate which is specific to the particular device. Okay. So this one is your world coordinate and this one is your viewing coordinate. Okay. World coordinate images look like this and viewing coordinate images look like this according to the camera analogy. Okay. Next come to the topic viewing parameter. Okay. Viewing parameters are 5. There are 5 parameters are in viewing. Okay. Viewing object or viewing pipelines. We can say that. So first one is our view, second one is view plane, third one is view reference point, fourth one is normal vector, fifth one is viewing distance. So let us discuss one by one in details what is view plane, what is view reference point and normal vector and what is viewing distance. Okay. First one is our view. That means viewing an object in any spatial position. That means in front of object, behind the object, middle of the object, inside the object and also left part of the object and right side of the object. In all direction we can view the object. Next one is our view plane. View plane means the plane onto which an object is projected in a parallel or perspective projection. That means the plane onto which an object is projected in a parallel or perspective projection. In which way? Okay. The view plane is usually placed at the viewing coordinate origin and the center of projection is positioned to obtain the amount of perspective desired. Okay. From the center point we can analyze the view plane or viewing coordinate origin. Okay. Viewing an animation sequence, usually the center of projection point is placed at the viewing coordinate origin and the view plane is placed in front of the scene. That means xy plane or xz plane or yz plane. In this way you can consider the view planes are there. Okay. Next one is our view reference point. The window is defined in view plane. The origin of this plane, which defines the position of the eye or camera, is called the view reference point. That means the point where is our eye contact or camera contact. That point is known as view reference point, or we can also say that VRP. A unit vector to this plane is the view plane normal. Okay. Then next one is our normal vector. A normal vector is a vector perpendicular to the surface. That means a unit vector to this view plane is the view plane normal, or also we can say that normal vector. That means it one is the perpendicular, the vector which one is perpendicular to the surface. Okay. Next one is our viewing distance. Viewing distance means the distance between the world coordinate to viewing coordinate is known as viewing distance. So today in this class we covered what is viewing pipeline and what are the different viewing parameters. Okay. So that's all in this class. All of you read completely and go through it.